Dear students, let us begin the third part of the lesson, in which you will learn about the computation of test statistics and obtaining the test critical values. The t statistic is calculated by taking the difference between the sample means and dividing it by the standard error of the difference. The formula for the t statistics is t equal to x1 bar minus x2 bar divided by standard error, where x1 bar and x2 bar are the sample means and SE is the standard error of the difference. The standard error of the difference is a measure of the variability of the difference between the sample means. It takes into account the sample sizes, variances and assumption of independence between the groups. Critical values. The test critical values, also known as the critical region or critical cutoff, are determined based on the chosen significance level alpha for the hypothesis test. The critical values are derived from the statistical distribution that corresponds to the selected test statistic. For example, when using the t-test, the critical values are obtained from the t-distribution. The critical values divide the distribution into the rejection region and the non-rejection region, that is acceptance region. If the calculated test statistics falls within the rejection region, it provides evidence to reject the null hypothesis. For example, investigate whether there is a significant difference in the average commute time between people who use public transportation group A and people who drive their vehicle. It is considered as a group B in a particular city. Statement of the hypothesis for this example. Null hypothesis: there is no significant difference in the average commute time between group A and group B. An alternative hypothesis for this example H1 is: there is a significant difference in the average commute time between group A and group B. Randomly select two independent samples, one from group A, public transportation users, and the other from group B, that is personal vehicle users. Determine the sample mean for group A, it is noted as a x1 bar, and determine the sample mean for group B, it is noted as a x2 bar. Compute the sample standard deviation for group A, it is denoted as a S1. Compute the standard deviation for group B, it is denoted as a S2. Select the appropriate test and calculate the test statistics and critical value using sample means, sample standard deviation and sample size. Compare both to make a decision. If the null hypothesis is rejected, we conclude that there is a significant difference in an average commute time between group A and group B. If the null hypothesis is not rejected, we conclude that there is insufficient evidence to suggest a significant difference. Then, difference between two population means. Hypothesis testing involving the difference between two population means is most frequently employed to determine whether or not it is reasonable to conclude that the population means are not equal. In such a cases, one of the following hypotheses may be formulated, that is, first one, H0 from mu1 minus mu2 is equal to 0. Alternative hypothesis, H1 minus mu2 is not equal to 0. The second one, H0 from mu1 minus mu2 greater than or equal to 0. Then alternative hypothesis is HA from mu1 minus mu2 less than 0. And third one, H0 from mu1 minus mu2 less than or equal to 0, and the alternative hypothesis is HA from mu1 minus mu2 greater than 0. When each of the two independent simple random samples has been drawn from a normally distributed population with a known variance, the test statistic for the null hypothesis of equal population means is Z is equal to x1 bar minus x2 bar minus mu1 bar minus mu2 bar 0 divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. The subscript 0 indicates that the difference is a hypothesized parameter. A study was designed to test the effects of disability on health promotion activities. The researchers developed a BHADP scale that is barriers to health activities among disabled persons for testing this effect. The scale was administered to a sample of 132 disabled and 137 non-disabled subjects with the following result. The mean score of disabled person is 31.83 and standard deviation of disabled person is 7.93 and mean score of the non-disabled person is 25.07 and standard deviation of non-disabled person is 4.80. The researcher wishes to know if he or she may conclude based on these results that in general disabled persons on average score higher on the BHADP scale. Hypothesis testing for this problem. The difference between the two population means and statistics were computed from two independent samples that behave as a simple random samples from a population of disabled persons and a population of non-disabled persons. Since the population variances are unknown, we will use sample variances for calculating the statistics. Since we have large samples, the central limit theorem allows us to use a Z test. That is Z test, it is Z equal to x1 bar minus x2 bar minus mu1 bar minus mu2 bar 0 divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. Then hypothesis or null hypothesis is h0 from mu d minus mu nd less than or equal to 0. Alternative hypothesis HA is equal to mu d minus mu nd is greater than 0. And alternatively, we can also define h0 from mu d less than or equal to mu nd and HA is equal to mu d greater than mu nd. Decision rule for this problem. Let alpha equal to 0.01. This is a one-sided test with critical value of Z is equal to 2.33. We can reject H0 if Z calculated value greater than or equal to 2.33. Then calculation of the test statistics is given by Z equal to 8.42 using their previous formula. Reject H0 since Z computed value it is equal to 8.42. It should be greater than 2.33. For this test, p value is less than 0.001 and since 8.42 greater than 3.89, we reject the null hypothesis at 0.01 level of significance and we conclude that on average disabled persons score higher on the BHADP scale than non-disabled persons. Dear students, let us summarize what we have learnt in this lesson. In this lesson, we have learnt about basic notion and significance of the testing the difference between two independent means and its importance in the context of comparing means. And also we learnt about objectivity in the context of statistical procedures, data collection, analysis and interpretation of the results and parent population with sample and statistic. Also we have learnt about the computation of test statistics and obtaining the test critical values with simple examples. Dear students, I hope you understood all the concepts. Also, these concepts will be helpful to you in your research. We have completed our lesson on hypothesis testing about the difference between two independent means and overview. Thank you.